So today again we are with one new problem, that is next greater element. So many folks have already gone through that problem. I know that, and there are various approaches by which you can do this problem. So first of all, let's read the problem description. So you have been given an array of size n, so where you have to find the next greater element from the array nearest element on the right side, which is greater than the current element. That is the definition of next greater element. So if there does not exist next greater element, you have to return -1. So let's see this example. You can see for 1 next greater element is 3, and for 3 next greater element is 4, and for 2 next greater element is 4, but for 4 there is no greater element, so it will return -1. So you can see the next larger element to 1 is 3, 3 is 4, 2 is 4, and 4 nothing. So since it doesn't exist, it is -1. So first we will see the brute force solution. You can use 2 for loop, and for every number you can check greater number in the right side. If you found the greater number, you just return that index, else you will return -1. So for that brute force approach, the time complexity, if you consider, is of n square, because we are using 2 loops to calculate the next greater element in the worst scenario actually. So the best scenario could be only the next greater element, all numbers are in sorted order. That could be the best scenario, and that is of n in that case. So if you talk about the space complexity, that would be of 1, because we are not using any type of extra space in that. Now to optimize more on this approach, we can use stack. So how we can use stack? So we will start iterating from the end. So let's say we are at 4. Now stack is earlier is empty, so we can say we will return -1, and we will insert 3 into the stack. Now when we are at 2, then what we will do, you can see we have already have stack in which 3 is remember that we are just pushing the index, not the actual number. So we are inserting index in the stack. So for 2, we can say the number is greater, so it will return the number that is present at the index I is equal to 3. So that is 4. Now we will insert 2, and we will move to the next iteration where I is 1 and n is equal to 3. Again we can see 2 is less than 3, so we will pop out 2. Remember that we are popping out the index, because at index 2 we have 2, which is less than index at 1. So we will pop out that, and then we will see that it has I equal to 3, and that is 4. So we can say the next greater element for I is equal to 1 would be I is equal to 3, that would be 4, and we will keep on doing that. So first we have an empty stack. This is the diagrammatic explanation of this one. You can see that. So for this approach, the time complexity would be of n, because we are iterating all that element only once. And for space complexity, we will take of n, because we are using stack for that. So we will pop out until the top element of the stack is less than and equal to the current element, because we don't need that. We just care about one case where stack's top element should be greater than the current element. If that is not greater than current element, we don't care. We just pop that out. We don't need that. And if stack is empty, we will return -1, else we will return the topmost element, and at the end we will push the current index into the stack, and that will keep on going. And yeah, that's all. You can see the time complexity, we already been discussed the time complexity and space complexity. So we have also seen the brute force approach that might work for the lower input test cases, but for larger test case we need to optimize that approach. And that's all. That's how you can do that using stack. So thanks